What's the clearest proof of alien technology we could ever find? Life is tricky. Bacteria, plants, even complex animals can leave traces that sometimes mimic simple chemistry. But technology leaves fingerprints that nature almost never forges by accident. Astronomers call these technosignatures, the long-lived, unmistakable marks of a civilization reshaping its world. Today, we'll cut through speculation and get precise. Because scientists already know the strongest evidence to search for, proof that could outlast entire species. Stick around while we explore atmospheric scars, planetary energy footprints, and the most durable traces of all. What if the air of a distant planet is already telling us a hidden story? 1. Alien fingerprints in the sky. Planets wear their history most openly in their skies. When we look at a star's light filtering through an exoplanet's atmosphere, we're effectively reading a chemical diary. Natural processes can stack those pages with familiar gases like oxygen, methane, or carbon dioxide. But the twist is this: while life can explain many mixes, only technology explains some. Take pollutants as an example. On Earth, our factories and refrigerants created exotic gases called chlorofluorocarbons. These don't occur naturally at all, and they linger for thousands of years. If we found an alien equivalent in the atmosphere of a distant world, it would be as decisive as footprints in wet cement. It would mean someone engineered their air, and their fingerprints remain. Even shifts in balance can be telling. A sudden sharp jump of carbon dioxide or methane over geologically short times suggests a world undergoing rapid industrial activity. In fact, scientists treat these spikes like a room that still smells of perfume hours after its guest has left. Civilizations may disappear, but the air they altered could hold their memory for millennia. And then comes planetary scale restructuring. Earth once underwent an oxygen revolution, natural life did it. But a repeat oxygen surge on another world, mismatched with biological growth, would feel engineered. Unearthly gases, timed shifts, subtle but sustained chemical oddities, all are skyborne signatures of thought and machinery. If pollution leaves fingerprints in the sky, civilization's appetite leaves shadows even harder to hide. Could we ever catch the glow of alien industry from light years away? 2. Planetary scale energy use. Every advanced civilization runs on power. You can change fuels, you can optimize efficiency, but there's no escaping physics. When you use energy, you give some of it back out as waste heat or light. This makes energy one of the best traces, because while nature produces plenty of warmth and brightness, it rarely organizes them in the ways cities and industries do. The most obvious clue would be daylight's other side: artificial light at night. On Earth, satellite images show webs of urban glow snaking across continents. If an alien planet harbored large settlements, their night sides would reveal tiny pinpoints or grids of illumination far too regular, too concentrated, and too spectral to confuse with volcanoes or lightning. Detecting city lights extrasolar is extremely difficult, but in principle, their very distinct patterns in brightness could betray them. Beyond light, waste heat is relentless. Any power plant, whether burning coal, splitting atoms, or focusing solar beams, radiates excess energy. At planetary scales, that heat reveals itself as infrared glow. Astronomers already plan for missions that could measure exoplanet temperatures with such precision that unusual warmth on a planet's dark hemisphere, where the star's energy shouldn't reach, could hint at technological fires burning there. You can't erase waste heat. It prizes open civilizations whether they want to be found or not. Then there are monumental signatures. Mega engineering projects like Dyson swarms, enormous solar collectors, or even planet shading structures. These would dim or reshape starlight in ways no ordinary dust cloud or planetary transit could duplicate. Imagine monitoring a star and noticing its light dipping in irregular, engineered-looking patterns. That's not an orbiting moon. That's architecture on a cosmic scale. We can apply a simple analogy from home. When a plane flies over a continent at night, pilots see whole regions glowing faintly at the horizon. Scale that outward. On interstellar distances, A technologically active world glows just enough in peculiar patterns that attentive telescopes can distinguish them from natural phenomena. Physics works against secrecy here. The larger the civilization, the more it radiates as a beacon. Waste energy, artificial light, and stellar modifications all point beyond biology. They point toward coordinated, repeatable, unnatural consumption. And unlike fleeting chemical bursts, energy traces stay visible so long as the civilization keeps running. Global industries can't switch off their footprints in the dark. But here's the thing. Atmospheres can lie, and even heat signatures invite alternative explanations. A volcano can spike greenhouse gases. A planet tidally stretched can radiate more warmth. But there's one signature that nature struggles to counterfeit. One signal that speaks with a voice both clear and enduring. Beyond energy and air, some evidence is burned into the very crust. If city lights are fleeting and pollution is suspect, then what would count as the longest-lasting smoking gun? What if the ground beneath an alien planet already holds traces that, by every law of physics, simply cannot be natural? 3. The strongest signature: nuclear and synthetic markers. Among all possible techno-signatures, some stand apart because physics itself guarantees they cannot be mistaken for natural processes. Radioactive isotopes top that list. On Earth, nuclear activity leaves behind isotope ratios that don't occur spontaneously. Atomic tests, reactor cycles, these all produce combinations nature simply doesn't replicate. If we find exotic isotopes in alien soil or asteroid dust, we'll know someone was splitting atoms. Volcanoes don't do that. Meteor impacts don't either. Nuclear traces are the most precise fingerprints of technology writ directly into matter. Then we move to synthetics. Think about plastics and other engineered polymers. These molecules were crafted to serve human needs: durable, moldable, persistent. Exactly those traits haunt the distant future. Even if humanity disappears tomorrow, plastic fragments will survive embedded in sediments for millions of years. They'll form a unique geological horizon, screaming, "Civilization was here." If alien civilizations use their own synthetic compounds, those too should resist weathering and end up stratified through time. Their chemistry won't align with random mineralization. Instead, they'll show deliberate design, repeating structures, optimized properties. Why do isotopes and synthetics count as the strongest signs? Because they combine two strengths: they persist for geological timescales, and they can't be easily confused with natural accidents. Their physics is universal. Any civilization that manipulates atoms or engineers materials etches patterns into the future. These aren't fleeting lights or subtle air mixes, they are enduring, artificial scars. And that's why many scientists argue, while atmospheric chemistry and waste heat might spark debate, a single, unambiguous isotopic anomaly or a layer of synthetic compounds would end the conversation. If these signals last millions of years, what if some are waiting out there right now, silent, but unmistakable beneath alien skies? So when we ask, what's the clearest proof of alien tech we could discover? The answer falls here: radioactive isotopes and synthetic compounds that nature can't produce. Those are the strongest, most durable signs a civilization leaves behind. Not subtle hints, but undeniable statements written in chemistry and geology. Now, picture it. A telescope reads an exoplanet's starlight and finds a chemical marker that shouldn't exist. Or a probe drills into the crust of another world and pulls out polymer fragments older than our species. That would mean we'd just glimpsed a technology beyond Earth. If imagining that gives you chills, stay with us. Subscribe to Infinite Echo. Your next cosmic mystery begins soon.